Let's find z to the fifth times w squared. Okay, remember from earlier examples, we found z is 12 cosine I sine 5 pi over 6, and w is 6 cosine I sine 3 pi over 4. Okay, all right, so to figure this out, let's figure it out one piece at a time. Remember, de Moivre's theorem says that if I want to find z to the fifth power, I have to do 12 to the fifth power times cosine I sine of 5 times the angle. And I'll multiply that times 6 squared, all right, 6 to the second power, cosine I sine of the second power, or 2 times 3 pi over 4. Okay, so 12 to the fifth power. Let's worry about that later. I am multiplying two complex numbers together, so remember to do that. You multiply the two magnitudes. I'll simplify that in a second, but that's 12 to the fifth times 6 to the second, cosine I sine. And then you add the exponents, the angles together. Well, 5 times 5 pi over 6 is 25 pi over 6, plus 2 times 3 pi over 4 is 3 pi over 2. Okay, let's go ahead and multiply this out now. 12 to the fifth times 6 squared is a ridiculously big number. 8,957,952 cosine I sine 25 pi over 6 plus 3 pi over 2. I'll do that off to the side. 25 pi over 6 plus 3 pi over 2. I want a common denominator. 6 would be the easiest, so I'll multiply the top and the bottom of the right expression, 3 pi over 2. Multiply that by 3. Top and the bottom by 3. So that gives me 34 pi over 6. Okay, so I want to write that. I want to bring that down at least to a first rotation. 34 pi over 6. So I'm going to start subtracting away 2 pi until I get to a nice familiar angle. So let's see. Do this in another color. So 34 pi over 6 minus 2 pi. That would be 12 pi over 6. That leaves me with 22 pi over 6 minus 12 pi over 6. That leaves me with 10 pi over 6, which is, of course, 5 pi over 3. So let's write this out. 8,957,952 cosine I sine of 5 pi over 3. All right, there we go.